All right, guys. Sorry for the interruption there. All is well though. Still no baby, but let's pick up where we left off in this last question. We were talking about how if we have something that cannot be factored by normal methods like quadratic or grouping, but I give you some sort of information about an x-intercept of the graph. What we can do with that is we can take the function and we can divide it by whatever factor would cause the x-intercept that I gave you. We should get a remainder of zero if it truly is an x-intercept. In this case, we did, and the result was a quadratic, and then we could take that quadratic and factor it, and we got ourselves to the fully factored form of this function. And so here's what we had. And so we were picking up here. We said, hey, multiplicity was 3. The function was positive. That matched up with what we saw at the beginning of the problem. So this is odd and positive. So that means we would be down and up for our end behavior. For x-intercepts, this one's going to have 3. Remember, we set each factor equal to 0 and we solve for x. First one we see is -5. That was the information that was given to us at the beginning of the problem. So that makes sense. There's an x-intercept at -5, one at 3, and another one at subtract 1 and divide by 2, so -1/2. Okay? And you will notice that a lot of these problems end up being pretty similar in terms of the graphing here. Nothing crazy new happening here. Let's plot these 3 x-intercepts. We got one at -5, one at -1/2, and one at 3. End behavior is down on the left, up on the right, and all of these have a multiplicity of 1. So we'll go through, and straight through again. Okay? So there is me using synthetic division in order to help us graph a more difficult type of function. Okay. One more example here, and then I will have some practice for you guys to try in the form of a worksheet. I'll put the answers to that here in the OneNote, and then remember, you guys have a quiz coming up during our next class. You can use notes on that quiz and written homework. So anything that you write down, you are allowed to use on that quiz. So make sure that you're writing things down as you watch the rest of this. And also, if you want to go back and watch any of the old videos and write things down, you are free to do that as well. All right. So this one is similar ideas, but it's going to have a little bit more to it. Let's try f of x equals x to the fourth plus 2x cubed minus 7x squared minus 20x minus 12. And I'm going to give you the information here that x equals -2 and x equals -1 are zeros of f of x. Okay, and I'm switching up the vocabulary here just because, where you look, you'll see different ways of writing this. When you see the word zeros, that is literally the exact same thing as me saying x-intercepts. Or another word that you might see for this is roots. So they might give you this as x equals -2 and x equals -1 are roots of f of x. Either one of those mean the same thing, so they can be said kind of in 3 ways: zeros, x-intercepts, roots. And our directions here are going to be to graph this. Now, the difference on this problem compared to the last one, a couple of things. First of all, the multiplicity here is 4. Okay, so it's raised to the 4th power. But also, I gave you more information on this one than I did on the last problem. On the last problem, I only gave you 1 x-intercept, but on this one, I'm actually giving you 2 x-intercepts. So we're going to use this information, but we're just going to have to use synthetic division a couple times in order to do this. One thing that might be helpful on this problem is just to write down, hey, if these are my x-intercepts, what factor would cause those x-intercepts? Well, I would get a -2 for an x-intercept if I had an x plus 2, and I would get a -1 if I had an x plus 1. Okay. So what this means is if I take this function and I divide it by either one of these factors, I should get a remainder of 0. And you can do this in whatever order you want. So if you wanted to start and take f of x and divide it by x plus 1 first, you could. Or if you wanted to divide it by x plus 2 first, you could do that. I'm going to go ahead and choose to try to divide by x plus 2. So in order to do that, what I'm going to do is I'm going to put a -2 in the box. And I'm just going to put a little note here. That means I'm dividing by x plus 2. And across the top here, I'll put the coefficients. So 1, 2, -7, -20, and -12. I'm just going to go ahead and do this process of synthetic division without talking too much. because it does get a little bit redundant since it's the same thing every time. So go ahead and watch me here. All right, and when we're done, we do see that we get a remainder, in fact, of 0 on this, just like we expected, because again, if something is an x-intercept, that means if we divide by the factor that causes the x-intercept, we should get a remainder of 0. So let's kind of collect where we're at right now. We just divided by x plus 2, so we know that the fully, or the factored form of this function is going to include an x plus 2. Then it's also going to include whatever we got as our answer here. So keep in mind this was an x to the fourth. So this one right here is going to be an x cubed. So this is going to be 1x cubed. Plus, this is x squared, but guess what? It's got a 0 as a coefficient. So I don't necessarily need to write that. You could if you wanted to. This is going to be x cubed plus 0x squared minus 7x minus 6. And that's where I'm at right now. Now, another difference on this one compared to the last one is on the last one, after we did synthetic division, we ended up with a quadratic. Well, this one is not a quadratic, it is a cubic, and that is why I actually gave us 2 x-intercepts on this one instead of just 1. So what we need to do next is we just divided by x plus 2. What we'd like to try next is let's take whatever's left and let's divide by x plus 1. Okay, and this is this works as we go along. So like if you take, for example, something like 24. Okay, 24 is divisible by 6, right? 24 divided by 6 is 4. But 6 breaks down into 3 times 2. So what this means is if I take 24 and I divide it, it doesn't matter if we pick 3 or 2 first, but let's say I divide it by 3, I get 8. And then, so I just divided by 3, I can then take 8 and I can divide it by 2, and I get 4. Okay, so I can go in whatever order I want. I'm just going to take whatever my result is and divide by the other number. This works in reverse as well. So if I had originally decided to divide by 2, 24 divided by 2 is 12. So I just divided by 2. And then if I divide 12, the result, by the other factor, 3, once again, I get 4. Okay, so it doesn't matter what order I do this in. Kind of like here, I told you it doesn't matter if you divide by x plus 2 or x plus 1 first. We just divided by x plus 2. But what we're then going to do is we're going to take this result and we're going to divide this by x plus 1. Okay, we call this process repeated synthetic division. Okay, so we have to do it more than once. Very creative name. We just call it repeated synthetic division. So let's go ahead and let's take this result and let's divide that by x plus 1. So that means we're going to put a -1 in the box. Okay, and I'm just going to put a little note here, and that means I'm dividing by x plus 1. And we're going to put these coefficients across the top. Now, keep in mind we skipped x squared. So this is going to be 1x cubed, 0x squared, -7x, and -6. Okay? And once again, if this is a factor of the original function, we're expecting to get a remainder of 0. So we'll check that out. Once again, I'm going to do the synthetic division process here without talking. You can try it on your own or you can follow along. All right, and we can see here when we're done, we do in fact get a remainder of 0 when we are finished. So everything is looking good so far. So let's once again collect our thoughts. Here's the number one thing that I'm going to see people forget. So a lot of people are going to say, okay, x plus 1, got that, good to go. What is this answer right here? Well, this was an x cubed, so this is an x squared. So this is going to go x squared, and then we're going to decrease in power, so minus 1x minus 6. And then they're going to stop right here. And hopefully what you're noticing here is I am forgetting something. What I'm forgetting is that at the beginning, I divided by x plus 2. So this does not just magically disappear. It is still part of the factored form of my function. So I now to make sure that I include that here. So I've really got x plus 2 times x plus 1 x plus 2 times x plus 1 times this remaining thing here. And this is a quadratic. Okay, and that's really the goal here is let's get this down to a quadratic for my last answer here, or for my last set of parentheses. And we know all kinds of stuff that we can do with quadratics, namely factoring. So let's go ahead and try. Let's see if we can factor this quadratic. So this is going to be x plus 2 times x plus 1. So I'll bring those down. Then I'll switch colors here. This quadratic should be able to be factored really quickly. We don't have to divide anything out of it. If there's a 1x squared at the front, I'm going to put an x and an x. Okay, I would be looking for factors of 1 times -6. That's -6. That add up to -1. Those two numbers would be -3 and +2. So I'm going to go ahead and write those down here. I do not have to divide anything out because right off the bat, x times x is already x squared. So that's looking good. So this is right here the completely factored form of this function. How did we do this? Well, we had to do synthetic division multiple times here because we were given multiple x-intercepts at the beginning of the problem. Okay, so let's move on to the graph next. Now, one other thing that you might notice with this is that there is a factor here that shows up twice. And as I've mentioned in other videos, if something shows up twice, x plus 2 times x plus 2, that is really x plus 2 squared. So this is x plus 2 squared times x plus 1 times x minus 3. Okay, there's the completely factored and sort of simplified and cleaned up version of this function. Let's go through and let's think about multiplicity and end behavior and all that good stuff. So the multiplicity of this function, this is going to be 2 plus 1 plus 1, which is 4, and this function is positive. Always encourage you to do this. So this is even and positive. Does that match up with what we had at the beginning? Yes, the highest power at the beginning was 4. And this function was positive, okay? So make sure you're not losing track of anything there. But everything is looking good right here. So this is 4 positive. Even positive is up, up. Okay, so that's one of the first times that we've seen this on some more difficult ones. So we're going to be same end behavior on both sides here. In terms of x-intercepts, this is actually going to have 3. So 1, 2, 3. Let's write them down. We've got -2, -1, and 3. Remember, we set each set of parentheses equal to 0, and we solve for x. And then we can go ahead and we can try to sketch this graph. Okay. All right, so we've got -2, -1, and 3. We know that our end behavior should be up on the left and up on the right here. And let's think about what's going to happen at each one of these x-intercepts. Let's start out with the one, the x-intercept at -2. That comes from this factor here. And what you'll notice is this exponent is even. And remember, we've said, hey, if the multiplicity of the factor that causes the x-intercept is even, we don't go through at that x-intercept, we bounce. Okay, so I'm actually going to have a bounce here at -2, and both of my other x-intercepts have a multiplicity of 1. So remember, at some point in time, turn around, we're going to go straight through at both of these x-intercepts. So go through and through, and my graph is matching up. When I get to that last x-intercept there, the puzzle is fitting together. It looks like we have to go through, and the multiplicity says, yes, it's 1. Let's go ahead and go through. And when we're finished, here's my graph of this function. Okay, so again, this process on this one is called repeated synthetic division. Really, it just means we had to do synthetic division more than one time. And then we are good to go. And once we get to that fully factored form, then it's just like what we've been doing before, where we get our multiplicity, our end behavior, and our x-intercepts, and we sketch the graph. Remember, there's worksheet practice, so check that out in the Google Doc. Answers are going to be up in the OneNote. Make sure you study for your quiz tomorrow, and bring all of your written material because you can use all of that when you take the quiz. Thanks, guys. Bye.